Alright, so to find the area, I'm going to use the pen to help me out. So if I draw in, I could easily with the additivity draw in two triangles and a rectangle. So here I know that this is a 2 by 5 rectangle, so that's 10 square centimeters. And here this is a triangle that has a base of 2 and a height of 5. So I know the area here is 5 square centimeters, and same thing here, that this is 5 square centimeters, which means that this is a 20 square centimeter using the additivity. Two triangles and a rectangle. Parallelogram, this is actually a rectangle, so I don't really need to do anything using the additivity principle because it's already in its pretty simplest form of finding the area. When I move to parallelogram 3, sometimes people like to try to draw a line down from N and over to M, but here's the issue. Let me zoom in here and show you why you shouldn't do this, and this is not a good one to use the additivity principle. If I look, let me scroll up just a little bit so I can get my move tool here. If I look here at what just happened, I can see that right there where where my line that I drew is coming, I'm going to delete this out, make it a little bit easier. Where I drew it to come right here, it's not at a grid, so it's not an easy one to actually deal with. Same thing here, when I came down here, that's not at a grid, so that's not an easy place to be trying to line up and use the additivity principle. Because if I look following the diagonal, there's no real easy place to kind of split and use the grid to help me with finding the area of this parallelogram. So here, parallelogram, additivity principle, maybe not the easiest. So if I go to number 4 and number 5, number 4 is not too bad because I could use my grid actually, and I can see that it snaps pretty easily into place, creating those triangles. And this is a 2 by 4 triangle, so I know this is 4, and I know this is 4 because they're identical triangles. And here this is 3 by 4, so that's that rectangle is 12. And if I add up my three areas, the two triangles and the rectangle, again, I have 20 square centimeters. The last one, this parallelogram that's turned, we'll say, where people think of it looking like a quote-unquote diamond. It's really a rhombus. What I can actually see here, what makes it unique, is that it actually comes to the midway point of the grid. So when I go to use my additivity principle, I just have to remember when I'm counting my base units that this is 1/2, 1.5, 2.5, 3.5, 4.5, 5 units across, and then my height goes up to Z. That's 1, 2, 3, 4 units for my height, which means 1/2 of base times height. This triangle has 10 square centimeters, and this triangle down here is identical, so it also has 10 square centimeters, giving me the 20 square centimeters. So I can just use the idea of using two triangles to make up this parallelogram, which technically is a rhombus. Okay, so I'm going to use my move tool, and we're going to look now at the moving principle. Oh, so we're going to. So with the first one here, if I think about the idea, and I can use the segment tool here, kind of show you where that split is. I could then think about taking this triangle, shifting it to right here, and now if I look at what I have in essence a rectangle that is 4 units across and 5 units high. Hence, by using the moving principle, I can create a rectangle much easier to find. And that rectangle is identical to this rectangle, so there is no reason to do any moving principle aspects to parallelogram number 2 because it is a rectangle. Alright, so parallelogram number 3 is one of the harder ones to understand about how the moving principle works, but it can be done. You just have to be very careful about how it is that you split up your rectangles, or split up into rectangles. So here, I'm use a perpendicular line to help me out. I'm going to create this perpendicular line here, and what I can see is that if I drew this line to the edge, it gives me a little bit better idea of what's going on. I can see it's kind of hard to match up the corner here, so maybe what might be easier to do is to look at this smaller triangle, which you can see it has a little bit of a gap at the end, and if I look, there's a little bit of a gap at the end here as well. So what I can do is I could say, look, we're going to undo that. Let's use the pen tool instead. If I just draw it over and I take this triangle here and shift it over to here, I can see that I have a 2x4 rectangle, and this goes away. Now, the biggest thing to pay attention to when this happens is look where this ends. It ends right here. There's that little bit of an angle, and look where this comes onto. There's that little bit of an angle, so that when I come and I draw my segment down from in, I can say, oh, it doesn't go all the way to make that gap. Well, why not? Well, it doesn't, because when I shift it over, it's going to end up filling in the gap over here, so that I end up with this being a 3x4 rectangle. So here I end up with it moving and giving me two rectangles, a 12 and an 8. So instead of it making one uniform one by moving, it ends up making two smaller rectangles, which still, when I add their pieces, gives me the 20 square centimeters. When I look at parallelogram number 4, this one's a pretty easier one to move, because I can take and see that this, say, take this bottom triangle, move it up here, and again it makes that nice easy looking rectangle, single uniform rectangle. It's 5 units tall, 4 units across, give me the 20 square centimeters. Alright, last one. Move this over. Alright, going to shift this up a little bit. So this one actually is kind of an interesting aspect. What I can do is I can take, and consider this being two triangles, take one triangle, move it to the bottom left side, take the other triangle, move it to the bottom right side, cross them out, and I look here, and I have 4 units for my height, and if I count across 1/2, 1.5, 2.5, 3.5, 4.5, 5 units across, I now have created a rectangle with 20 square centimeters. So the moving and additivity principles can be used if I've got the gridded paper. It just takes a minute to go through and label it all out.